Woohoo. Working, huh?
There we go.
Yep. I keep forgetting. It gets locked somehow with my fat fingers. So this look here, if you're state A, if you go to A, your output is 0. That's the way that is. State B here, also your output is 0. So if you state A and your external input is 0, you stay there. But if your input is 1, you go to this one, and you get nothing. If you're state B and your input is 0, you go right here, and you get nothing. If you put a 1, you go to state C, and your output is 0 here. If you're at C, your input is 1, you stay here. If it's 0, you go to state D, and when you get to D, your output is always a 1. If you put a 0 here, you stay where you are. If you put a 1, you go to state E. At E, your output is always a 1. If you at E, you put a 0, you go back here. If you put a 1, you go to state F. Your output is 1. If you put a 1 here, state F, you stay where you are. And if you put a 0, you go back to state A.
Are we supposed to memorize how this works, or is this what the question looks like?
No, that's the question. We have no idea what that does. So I'm giving you this problem. I said, design a circuit that if you're state A and you put a 0, you stay there. But if you put a 1, you go to state B. If you have B and you put a 0, you go back to A and you get nothing. But if you put a 1, you go to C and you get nothing. If you're here, you put a 1, you stay there. You put a 0, you go to this one. Now you get an output here because you're at this state. If you put nothing here, you get another output. But if you put a 0, you get, yep. And if you put a 1, you go to that one. If you're here, you put a 0, you go back to this, you get an output. If you put a 1, you go to this one, you get an output. I forgot to write the 1 here. And if I'm at this stage, if I put a 1, I stay here, I get a 1 for an output. If I put a 0, I go back to that one. So that's the state diagram. How many states do we have? 6 states. So guess what? How many flip-flops? Has to be greater than or equal to 6. So would 2 flip-flops do it? No. So the number of flip-flops should be what? 3. And maybe what I'll do, I'll use for the first flip-flop 1, maybe I'll use T flip-flop, just to mix and match. Flip-flop 2, I'll use SR. And flip-flop 3, because we didn't touch any of them, I'll use D. So I'm trying to cover all of them in one.
What? You said it's greater than or equal to 6. You're saying, oh, is it because of
No, because if you use 2 flip-flops, you can only have 4 states.
only 4 states?
So I have 6 states. If I use 3, I can go up to 8 states. Mm-hmm. So notice I have 2 unused states. We're going to decide what to do with the unused state.
So it's by 2.
So 2 unused states here. And if I want to make life easy on me, since I don't really care what that problem does, I'll make it do what? Don't care? I can use don't care for them if I want to make life easy.
That's for the...
Because there's 2 states. Notice I can label state A as my 0, 0, 0. State B as my what? 0, 0, 1. State C as my 0, 1, 0. State D as 0, 1, 1. State E as 1, 0, 0. State F as 1, 0, 1. What about 1, 1, 0 and 1, 1, 1? Those are my unused. I'm not using them because I'm using 3 flip-flops. So that's the coding of the states. I don't need a calculator here. You never do math here. I need a graph paper so I can write things in it. Nice and small, fit them inside the graph paper. Since you have 3 flip-flops and you have 1 external input, how many inputs you gonna have then? 4. What are they? The outside input, that's this guy, the 0 and 1. See him? And the current states, there's 3 of them. Q1, Q2, Q3. So my inputs here are the current states, or current state, and X. There's no space here, I'll do it this way. The input. So we have Q3, Q2, Q1, and X. And let's list all the combination for them. It could be 0, 0, 0, 0. Well, I'll move this one here because it looks like crooked there. Could be 0, 0, 0, 0, 1. Maybe I'll do it. 0, 1, 0, 0, 1, 0, 0, 0, 1, 1. Next one, I'll leave a space between them. 0, 1, 0, 0, 0, 1, 0, 1. The next one, 0, 1, 1, 0, 0, 1, 1, 1. The next one, 1, 0, 0, 0, 1, 0, 0, 1. The next one, 1, 0, 1, 0, 1, 0, 1, 1. The next one, 1, 1, 0, 0, 1, 1, 0, 1. And the last one, 1, 1, 1, 0, and 1, 1, 1, 1. Next state. We call them what? Q3 asterisk last time. Q2 asterisk. Q1 asterisk. And we have an outside output. We'll call it Z. That's your output. And let's look at our state diagram here and see. If I'm at state A, which is 0, 0, 0, if my input is 0, according to this one, what will happen? If my input is 0, I'm going to stay there. So it's 0, 0, 0. And what's my output?
0.
0. But if I put a 1, I go to state B, which is what? 0, 0, 1. And what's my output? It's also 0. If I'm at state 0, 0, 1, that's B. And my input is 0, I go back to state A. That's 0, 0, 0, I'm getting nothing. But if it's 1, I go to C, which is 0, 1, 0, and I get nothing. If I'm at state C, which is right here, 0, 1, 0, my input is 0, I go to D. D is what? 0, 1, 1. And my output is what? 1. But if it's a 1, I stay there at 0, 1, 0, and my output is 0. Now I'm at D. Can you see still D on the screen? Yep. Here is D. State 0, 1, 1. If my input is 0, I stay there and I get an output. But if it's 1, I go to E. E is what? 1, 0, 0. And I get an output. If I'm at E, my input is 0, I go back to D, which is 0, 1, 1. My output is 1. But if it's 1, I go to F, and F is 1, 0, 1. My output is 1. And the last one, state F, which is 1, 0, 1. If my input is 0, I go to A, which is 0, 0, 0. My output is 0. But if it's 1 here, I'm going to stay where I am, which is 1, 0, 1. My output is 1. And these are the two unused states. And that's up to us what to do with them. So what do you want to do with them?
It depends on the what we're doing, I guess.
You're the designer.
If it was a vending machine,
You're the designer. Unless somebody tells you what to do, you got to make a decision there. What do you want to do with them? Do you want to reset, go to 0, 0, 0, and give them an output? Do you want to say, I don't care? It's up to you. So somebody gives me an idea. What do you want? Don't cares? Okay, you don't care what happened? Because the problem doesn't state anything on them. He's saying, I don't care what happens here. I don't care if it resets or not, if it gives them candy or not, if they get it, oh well. 2 or 3 times out of the life of the machine, I'm not going to go broke over it. And now I need to know this. So the first flip-flop, I'm saying the third one is what? D flip-flop. So this is the D flip-flop. D3 is number 3. And number 2 was what? SR. So that's the SR. And number 1 was a T flip-flop. I need color coding. 3 colors, there we go. So the first flip-flop is the 3. That's this with this to get that. The second one, this and this to get these two. And the third flip-flop and that'll give me that one. Let's go back to these flip-flop, revisit them quickly, because I need to get the excitation table for them. Let's go back to the flip-flop and do the truth table for each one and see if we can work them backward. And we looked at them initially in chapter 7, or maybe before chapter 7. Those flip-flops were earlier than 7. Maybe chapter 6. Here's the T flip-flop. Here's if the current state, and this is T, and this is the next state. 0, 0, 0, 1, 1, 0, 1, 1. When it's 0, 0, next state is 0. When it's 0, 1, when T is actually 1, what happens? It toggles. When this is 0, that turns to a 1. When it's 1, it turns to a 0. When T is 0, it doesn't do anything. It leaves it alone. So when T is 0, your state stays the same as before. When it's 1, do the complement. It used to be 0, it becomes 1. It used to be a 1, it goes to a 0. So to work this backward, if I tell you what T is, can you tell me? Well, we can do it this way. The current state and the next state. Tell me what T is. This is the current. This is the next state. Can you tell me what T should be? From 0 to 0.
0.
T will have to be 0. From 0 to 1.
1.
T will have to be 1. From 1 to 0. T will have to be 1. And from 1 to 1, T will have to be what?
0.
How about 0?
Really?
If it stays the same, T is 0.
Oh, right, I wasn't. Yeah.
Since I did the first flip-flop, I did the T. If it stays the same, T is 0. If it changes, T is 1. I can do the last one, the column 3 column here. Look at the yellow. 0 to 0. No change. T is 0. 0 to 1. 1, right? 1 to 0. 1. 1 to 0. 1. 0 to 1. 1. 0 to 0. 0. 1 to 1. 0. 1 to 0. 1. 0 to 1. 1. 0 to 1. 1. 1 to 0. 1. Complement. 1 to 1, that's the same. 0. 0 to don't care. Don't care. Because it could be 0 or 1. And all these 0 to don't care. Right? So now we finish the T flip-flop. Maybe I'll look at the next flip-flop. Let's look at the next flip-flop. Where is the table for that SR flip-flop and JK flip-flop? If you remember, the SR flip-flop,
Is a set reset.
set reset, yes. When it's 0, 0, the next state will be the same as the previous. When it's 0, 1, it's always what? 0. When it's 1, 0, it's a 1, and it's 1, 1, what? Not allowed. There's the current state, there's the next state. And this is what S and R should be. 0 to 0, 0 to 1, 1 to 0, 1 to 1. 0 to 0, I can accomplish that by putting either what? 0, 0 or 0, 1. 0, 0 will keep it the same, 0, 1 will force it to be 0. So as long as S is 0, don't care about R. Zero to 1. Well, it can't be this one. It can't be this one. It has to be what? 1, 0. Once you put a 1, 0, it's going to force it to be a 1. 1 to 0. 0, 1. And 1 to 1, I could do two things. I can do this one by putting 1, 0 or 0 to 0. Don't care for S, R is 0. So let's come back here and see if we can do the SR. There we go again. The first one, 0 to 0, 0 and don't care. Zero to 0, 0, don't care. 0 to 0, 0, don't care. I like when you have a lot of them. 0 to 0, 0, don't care. 1 to 1, 1 to 1 is what? Don't care and 0? 1 to 0, that's 0, 1. 1 to 1, don't care and 0. 1 to 0, 0, 1. 0 to 1, 1 and 0 is it? 0 to 1. Let's keep going here and see if I can finish it. Can fit them all here. This is not going to work here. It's going to slide off. So I'll just move this one out.
Was it in 0 to 0? Last one?
Last one. 0 to 1, 1 and 0. Last one is 0 to 0, which is 0 and don't care, right? Where am I? Right here now? 0 to 0, 0 and don't care. 0 to 0, 0 and don't care. Don't move, paper. 1 to don't care. That could be 1 to 0 and 1 to 1. Really don't care and don't care. Because if it's 1 to 0, that's 0, 1. If it's 1 to 1, don't care and 0. I mean, you can decide what you want to do with it. Because I'm going to make it go to 0. I'm going to make it go to 1. I should have made them go to 0. It'd probably be easier. Because that'd be 0, 1. But here, don't care. I don't like that don't care for one reason. Why? If S and R goes to 1 and 1, it's not really allowed. The reason it's not allowed because Q and Q naught will be the same. And that's not supposed to be. I should have chose a better one, either not use SR here or give it go to 0. Be specific. So I'll make sure it does not hit the 1, 1. Everyone see why I don't like it? But you want it to go to don't care. So we're just going to hope it never hits 1, 1. If it does, Q and Q naught will all be, both will be the same. That's the only problem with it. It's not like the system is going to explode. Because Q naught, there's Q1, Q1 bar. One's supposed to be 1, one's supposed to be 0. If one is 0, the other one is 1. When you put 1, 1, you're not going to have 0 and 1. You're going to have them the same. How can it be a bar if it's the same? That's why we don't like it. And now we need the third one. And the third one is the D flip-flop. And if I can find the D flip-flop, we can list it there. Where is the D flip-flop? If not, I'll tell you what it is. Here's the D flip-flop. If it's D and Q, and this is Q naught. If D is 0 and Q is 0, you get a 0. If D is 0, Q is 1, you get a 0. If D is 1, Q is 0, you get a 1. If D is 1, Q is 1, you get a 1. So basically when you look at it,
It's whatever Q.
whatever D is, right? So if you look at it backward, 0 to 0. If Q is 0, you're getting a 0. 0 to 1, that means D is 1. 1 to 0, D is 0. 1 to 1, D is 1. So notice this and this are the same. That's why it's called D flip-flop, data flip-flop. Your next state will be the same as D. When D is 0, you get a 0. When D is 1, you get a 1. That's actually a nice design here because I don't have to kill myself here. I just copy this row or this column. 0, 0, 0, 0, 0, 0. I'm trying to just line them up, make sure I stay. 0, 1, 0, 1, 0, 1. Don't care, don't care, don't care, don't care. So now we're done with them. K-map for each one of these is 1, 2, 3, 4, 5, and I'm done.
Alright.
Let's do a K-map for each one of these. Oh wait, I have my K-maps here. Perfect.
Station market was came out sheets.
There we go. I like these. So I just put a tape on them so when I scan them, they don't get stuck inside the machine. They won't be happy with me if they get stuck inside the machine. Then from the temperature, they melt. The plastic.
Oh.
I'll do all of this instead of drawing that one. It's like the same amount of work probably, but it looks nicer. There we go. That's the first one. So it's going to be, I'll begin with Z here, and I'll do D3 here. This is Z here. My inputs are Q3, Q2, Q1, and X. Here's Z, 0, 0, 0, 0, 1, 0, 1, 1, 1, 1, 0, 1. Don't care. Not a nice design, but To group that one, I'm looking at it. I can take these guys here. So the first one we'll read as what? Is that Q2? And up and down, what do we have? X bar? To get this one, that group here, which is again Q2, Q1. To get these two ones, how about that group there? Q3 and X. There's one more one to group right there, but I'll take these four. Which is what? Q3, Q1 bar. Now, the D shouldn't be bad. There's a lot of zeros I see in it. Zero, one, 0, 1. So the D here looks like there's one group. It's the same gate. I can grab it for both of these. That's good. And that will be what? Q3, Q2, Q1, and X. That's Q3, X. Well, I gotta take this one now. I can only take it with this one.
Yeah.
Q2, Q1X. Now I need two more for the S and R and one for the T. There's the S and R. Let's attach it right there. I think I'll be okay when I scan them. Okay. So this is S2 and R2. Let's see what we have. I have 0, 0, 0, 0. Don't care 0, don't care 0. 1, 0, 0, 0, and don't care. Q3, Q2, Q1, X. If I'm seeing it right, there's only one group. And that's what? Q3, Q1 bar, X bar. Q3, Q2, Q1, and X. Let's look at R. First four, don't care. 0, 1, 0, 1. 0, don't care. And the rest don't care.
Would you take 8 here? Or?
I will take 8, definitely. So I only have what? X? Need one more.
T, right?
T. Let's cut the last piece here. I like having these. Let's look at T now. The paper felt so thick. Probably the other pieces on it. And that's T. Bless you. Q3, Q2, Q1X. 0, 1, 1, 1. 1, 0, 0, 1. 1, 1, 1, 0. And don't cares.
Top right, bottom right.
Top right, and well, I could. I'm looking to see if I need that because I might be able to get away without. If I just take these four here, because I got to get that. Well, I can do this one with that one, I guess. That will take care of that piece. Let's look at the must here.
The one on top can only go with the one to the right of it.
Yep. I can take these two here. 4.
That's what I was
Yep. So if I take this one, what do we have? Q2 naught, Q1 naught, and X.
What will we do about this from 2?
Which one?
Number 2? The bottom left.
Here?
Yeah.
I didn't decide yet how I'm going to handle it because I can go with these two, I can go these two, I can go this and this.
I would deal with the one in spot 4 first because it can only go right.
Yeah, 4 is the, yeah, you're stuck with 4. You don't have a choice. That's not a, it's not going to change anything. And that will be,
And top right can either go with
that'll be Q2, Q1 naught, X naught. Now I'm looking here.
I would agree with Lucas. I would go top in the top right, bottom right, because you get the bars out.
it. Doesn't
Yep.
really matter.
Yep, it's still going to be 3. I'm trying to see if I can eliminate 1.
You're going to be overall.
Uh,
no matter what you do.
yeah.
I just want to get rid of the thing that's
It doesn't look like I'm going to be able to get anything out.
There's
So-
tiny knot gates there, right?
So that will be what? Q3
Then,
and X naught.
oh, there's an next one. Oh yeah, yeah.
Yep.
Okay, never mind.
And now I got this one. I can take these two guys together. Q3 naught, Q2 naught, Q1, and finally this one. And I don't see beside this one, which is what? Q3 naught?
Well, you could take the don't care if you want to not overlap, but
Well, I could, yeah, but it wouldn't. I mean, it's not going to make it a group of 4. Yep. Q1X. And now I just got to attach all these circuits. So I got 3 flip-flops. The first one is a D flip-flop on the left side, SR, and a T. Almost done. So if I'm building that, that's the first one, the T flip-flop. It has 2 input, 1 output. That's number 3. It has 1 input. That's number 3. It has 2 outputs. Q3, Q3 naught. That's T3 here. The next one, right next to it, I think that's the height here. The next one is right next to it. That's the SR. S2R2 has Q2 and Q2 naught. And the last one is what? The D flip-flop, the third one? I only have like 4 pages, but we've been working at this problem the whole class. And that's D1,
Wasn't D 3?
Q1, Q1 naught. I thought, let's see. Oh yeah, D is actually this one. D is the third one. And T is the first one. T1, and this is D3. The way we label them, you know, first one, second one, third one. If you look T on the right, I label them S and R here, D on the left. So this way I'll stay consistent with them. And now it's going to attach to each one, and there's my output Z, which is going to be a big OR gate going to it, lots of things. There's a clock running all of them, because you want everything to be synchronized. Oh, I just realized one is actually shorter. Huh? Or one is longer. That one's longer. That's the clock. One is longer. The other. So we have a clock synchronizing everything. And what's going to each one? Let's look at it. T flip-flop. That's this one. Oh, God. It's a big gate, OR gate, with lots of AND gates. So maybe I can make the OR gate really small. With how many AND gates? 1, 2, 3, 4, 5. Oh yeah, good luck. I was trying to be neat. I give up on being neat now. And what's going to it? Q2 naught, Q1 naught next. The next one, Q2, Q1 naught, X naught. Q2, Q1 naught, X naught. Q3 and X naught. Q3 naught, Q2 naught, Q1. Q2 naught, Q1. And the last one, Q3 naught. If you can read them, Q1 and X. Good luck reading them. That's T1. But that's really what that is. 5 AND gates all together, and that's going to it. So basically, it looks like, what do you attach? You attach all these. We have an external input, X. X is coming in somewhere here. So between X and these guys, that's where you attach to them. Now, yes, yeah, like for example, Q2 naught, that's the Q2 naught. See this one here? You take the wire, attach it right here. Q1 naught, that's this one. Attach it right there. And X, which is the external input. This one, Q2, which is this one. Q1 naught, that's this one. And X naught, going to it. This one, Q3, that's from here. And X naught, going to it. This one, Q3, from here. Q2, from here. And Q1, from here, going to it. Now, the good news for R2 and S2, they're really simple. This go into it X. This is one AND gate here. And that's Q3, which is directly from here. I don't want to put a bar on it, just Q3, no bar on it. Q1 bar, that's from here, and X. And this one's an OR gate with two AND gates going to it. And what's going here? Q3 and X. And from here we have three things. Q2, Q1, and X. And finally my output here, Z, which is an OR gate. And what's attached to that OR gate? 4 AND gates. What's going to it? Q2 and X bar. Q2 and X bar, not Q bar. Q2 and X bar. Q2, Q1. Q3 and X. And the last one, Q3 and Q1 bar. And again, they're all coming from here. And that will decide what you're going to be getting.
Where did you get the Z values from?
That's your output. That's right here.
Oh,
And that's my whole design. If I can just make it a little bit nice and neat, I can graph it. There is actually some software on the market that you can list the stuff that you need, and that software will tell you what size board to use and what's the best way to attach them. They'll minimize the size. All big companies, that's what they use. They just list all the stuff. We know the parts number for each one. We list them what we need there. And that software will take them, try and figure out, because they know what the chip is. We need a T flip-flop, SR flip-flop, D flip-flop. They know the number for them. They will look at them and say the best way to put this one this way, that one this way, attach this one here, put the OR gates here, the chip, and connect the wires. Minimize all the wires, everything.
Would it make any difference if you did like 2 D flip-flops instead of one of each?
I could have done the 2D flip-flops and one.
Would it be any like harder or no?
Well, no, because actually it'd be the better design, because instead of using a separate chip now, because on the chip there's 2D flip-flops. So now I'm using 3 chips here, but I just wanted to go over the T flip-flop, the SR, and the D, because we didn't cover them. So I opted to go with one of each, so you get to see the excitation table for each one. Because I was like, last time what we did is only that JK. We never discussed the T, the SR, and the D. So I figured in this example we'll cover them all in one problem. Now what I could have done differently, I could have made my life easy. How? I said for this one, use a mux to drive it.
Oh, yeah.
Right?
'Cause yeah.
I can guarantee you that. I put that last year on the final exam. To cover all the topic, I said use a mux to drive T1. 8x1 mux. What do you attach to it? You know? So you have to go back and says, never mind now do the K-map here. Let me figure an 8x1 mux. Use a decoder, for example, and OR gates to drive maybe this one. I don't know. I'll mix and match. So that's what I did.